Our next topic is step response of RC circuits. Now, when we say step response, meaning the behavior of our RC circuit when the excitation is a step function. So the step function can be either a voltage or a current source. For figure 7.40, we have here two circuits A and B. So for circuit A, we have here a switch. Our switch is connected to the capacitor at t equals 0. So the switch is closed at t equals 0. Take note, at t equals 0, our capacitor sees a voltage source Vs. Now, for t less than 0, wala tayo source voltage at ang capacitor is walay nakita nga source voltage. So basically, 0 iyang voltage source. Now for circuit B, we have here V as U of t as a source voltage. No? Take note, V as U of t is a step function. Now, why step function? So, from the previous topic, we know that ut is a unit step function. Gimultiply lang ang u of t sa Vs. So, therefore, ang atong Vs is pareho siyang behavior sa u of t, pero lahi silang amplitude. Sa u of t, ang amplitude is 1. Sa Vs u of t, ang amplitude is Vs. So again, as a review, ang u of t has a value 0 at t less than 0, and then a value of 1 at t greater than 0. And thus, ang Vs u of t has a value of 0 at t less than 0 and has a value of Vs at t greater than 0. So basically, for the circuit B, ang atong capacitor, combination sa RC, resistor and capacitor, is nasupplyan siya o source voltage Vs at t greater than 0. But at time less than 0, wala siya voltage na nag-supply. Now take note, A and B are the same circuits or equivalent circuits. So we can, for example, if we want to find V of t, we can use circuit B. Okay, so our goal initially for this topic is we first derive the function V of t, which is the voltage across our capacitor at any time t. So, we use circuit B to find V of t. Now, take note, let's say this is node A. Node A. So, we say, by KCL at node A, this one is IR, and this one is IC. IR equals IC. IR is V over R. Voltage across the resistor is Vs U of t minus the node voltage A or VA over R. IC equals C dV dt. Take note, the node voltage VA equals V, implying Vs U of t minus V over R is equal to C dV dt. Take note, this equation is a differential equation. And also, this equation is variable separable. Again, our goal is to find V of t. So we solve this differential equation. Natay dV over Vs U of t minus V equals dt over RC, integrate from 0 to t, this one from V sub O to V. Take note, what is V sub O? Note, V sub O, itong V sub O is our initial voltage. Initial voltage across the capacitor. Okay, so integral of dt RC is 1 over RC. 1 over RC is constant, so integral of dt RC is 1 over RC. Integral of dt from 0 to t equals, take note, ang atong t is gi-integrate from 0 to t. So therefore, take note, ang atong u of t has a value of 1 for t greater than 0. So therefore, pwede natin siya isuwat as dv, okay, Vs times 1 or simply Vs minus V. So 1 over RC dt, integral dt is t from 0 to t, integral of V sub of V dV Vs minus V. But what is integral of dV Vs minus V? Note, integral of dV Vs minus V, we let u equals Vs minus V, implying du equals negative dV or dV equals negative du. So, integral of dV Vs minus V equals dV is negative du, so equals integral of negative du over Vs minus V is u equals negative integral du over u equals negative ln u equals negative ln u ln Vs minus V. Okay, 1 over RC t from 0 to t is 1 over RC t minus 0 or 1 over RC t. So integral of dV Vs minus V equals negative ln Vs minus V from V sub O to V. One over RC times time equals negative ln Vs minus V minus ln Vs minus V sub O. Okay, so we can divide everything by 1 or negative 1. So negative 1 over RC time equals ln Vs minus V minus ln Vs minus V sub O. Take note, ln of A minus ln of B is equal to ln A over B. And so, negative 1 over RC times time equals ln Vs minus V, Vs minus V sub O. Okay, cancel ln. We have E negative 1 over RC time equals Vs minus V over Vs minus V sub O, implying E negative 1 over RC times time, Vs minus V sub O equals Vs minus V, implying our V equals Vs minus V sub O, E negative 1 over RC times time, implying V or V of t equals Vs. Okay, we can distribute V negative, so we have plus VO minus Vs, E negative 1 over RC times time, which is the voltage across our capacitor.